Hello, ladies and gentlemen, and welcome back to more of the 2000 Cayley paper. That's the grade 10 paper put out by the University of Waterloo. And we're up to question 18, which says if a, b, and c are distinct positive integers, such that a, b, c is equal to 16, then the largest possible value of a to the b minus b to the c plus c to the a is... Okay. So some things I'm noting right off the bat. A, B, and C have to be distinct positive integers that multiply to 16, and there are not a lot of those triples. 16 does not have a whole bunch of factors. So something that might be advantageous to do would be to write out the possible A, B's, and C's we could have. And we want the largest possible value of this expression. Well, notice that we're subtracting off B to the power of C. Okay? So that means that we're probably going to want to minimize that. Now, since these guys have to be positive integers, we'll probably want b to be something like 1, and then 1 to the power of anything, doesn't really matter. And then a to the b will become a to the power of 1. So we'll be having a subtract 1 plus whatever c to the a is. So c to the a, I think, is the term we're really going to want to watch out for. But, as I say, distinct positive integers multiplying to 16, there are not a lot of those. So how about we list out the factors of 16 and see what possible A, B's, and C's we can get. So the factors of 16 are 1, 2, 4, 8, and 16. Okay. And we want distinct positive integers that multiply to 16. Okay, well, out of these, what triples can we get? We have 10 possibilities, because there are 5 of them. Choose 3, so that's 5 factorial divided by 3 factorial divided by 2 factorial, which is 10. So we want to choose distinct ones. We could have 1, 2, 4, but that equals 8. We could have 1, 2, 8, so that one works. We could have 1, 2, 16, but that's too big. We could have 2, 4, 8, but that's 64, so that's not going to work. Oh, I'm missing some. Sorry, we could have 1, 4, 8. That's also 32, so that's no go. We could have 1, 4, and 16, but that's too big. That's 64. We could have 1, 8, and 16, but of course that is also well too big. It's 128. We could have 2, 4, and 8, but as I said, that's too big. That's 64. We could have 2, 4, 16. That's too big. We could have 2, 8, 16. And that's going to be 256. And that's too big. And then finally, I guess we'll write them over here. We could have 4, 8, and 16. But that's going to be 512. So it looks like the only possibilities are A, B, and C must be among 1, 2, and 8. Okay. So we have the equation A to the B minus B to the C plus C to the A. Now it looks somewhat symmetric. I mean, there's clearly a pattern going on here. A to the B, and then we take B to the C, and then C to the A. But we don't have an A to the B and a B to the A. So this thing isn't actually symmetric. So the order of which one is A, which one is B, and which one is C definitely matters. If we have 6 terms, so order matters. So we have 3 terms, A, B, and C. The order in which, 1, 2, and 8. The order of them does matter. So A, B, and C could be equal to 1, 2, and 8, and we'll do the calculation there in a second. or it could be 182. So what we're going to do is we're going to write out each case, and we're going to compute what this expression is and see just which is the biggest. I think it'll be the one that is 2 to the power 8. So I think it's going to be this one right here, but, or sorry, this one that I'm about to write, 218. So I think c to the a is what we need to maximize, and so, oh no, this isn't the one either. I need 812 is the one I think is biggest. Okay, so when you're doing these, if you know permutations and combinations, which is something that, if you're serious about writing these contests, you should be aware of at least by now, you'll know when you're done because you'll have written out the total number of permutations. I know that if I'm rearranging 3 objects, it's 3 times 2 times 1, which is 6. So I have 6 possibilities. And if you're not aware of that stuff, by all means, go ahead and learn permutations and choose notation. It's very powerful. But if you're not aware of that and you're still trying these contests, one thing you can do is just try and be very methodical when you write them out. So I've done all the ones that have 1 at the start. Now I've done all the ones that have 2 at the start. So these last 2 will have 8 at the start. We'll get 8, 1, 2. I'm just going in order. And then 8, 2, 1. And I think this one's going to be biggest, because it's got that 1 in the middle that makes b to the c as small as possible, and it's got c to the a being pretty darn big. So let's see what we've got here. 1, 2, and 8. So 1 to the power of 2 is 1, minus b to the power of c, so 2 to the power of 8. 2 to the power of 8 is 256. And then plus 8 to the power 1. That's a negative number. This isn't going to work out well, but let's compute exactly what it is. Negative 247. That wasn't even among our possible answers. Okay. 182. So 1 to the power of 8 is 1. Minus 8 to the power of 2. That's 64. 8 squared. Plus 2 to the power of 1. So this is going to be negative 61. That's also, I mean, that's the best so far, but that still wasn't even in our list. 2 to the power of 1 is 2. 1 to the power of 8 is 1, and then plus 8 to the power of 2, so 64. So we get 65. That's nice, but it's still not amongst our answers, which is a shame. Our answers are typically much higher than this. Okay. 2 to the power of 8, that's 256. Minus 8 to the power of 1, plus 1 to the power of 2. So 1 squared is just 1. And we have 249, which I think is actually on our list, so we're doing well. Alright, now this is the one that I thought was really good. 8 to the power of 1, that's 8. Minus 1 to squared, that's 1. Plus 2 to the power of 8, which is 256. And we'll get 256 plus 8 minus 1, so that's 7. So we get 263. And now the last case, 8 to the power of 2, that's 64. 2 to the power of 1, so minus 2, plus 1 to the power of 8, so that's 1, and we get 63. So our clear winner is 263, which I believe is the largest value. There it is, it's D. So if you had taken a guess on this one and just chosen the largest possible value, you would have been right, but you wouldn't have been very confident because you guessed. But definitely, that way if you had done trial and error and you were able to somehow get 263, you would certainly have stopped looking because you definitely had a way of doing it. So we get an answer of D. Okay. Nice little question. Certainly, I thought it was nice. What's interesting was that we had 2 steps. We actually had to figure out all the possible ways that we could have 3 distinct positive integers that multiplied to 16. And that took us a little while, but it turned out there was only one case to consider. And so that was the sort of the first part of the question. And then we had this second part where we had to rearrange and basically just do some computation. But that's question 18, and we'll take a look at question 19 in the very next video. I hope to see you guys then.